In the previous video, we talked about the first two types of study designs, case studies and correlational studies. We also learned that correlational studies can show us if two variables are related, but they can't say anything about why. That is, correlational studies can't provide definitive evidence that one variable actually causes another. But what if causation is really what we want to know? Can researchers ever make a definitive statement that one variable actually causes a change in another variable? They can, and this is where the third type of study design, experiments, comes in. Experimental studies are a type of study design where researchers manipulate one or more variables and observe their effect on a particular outcome. In an experimental study, the variable that the researcher manipulates or changes is called the independent variable, and we sometimes just abbreviate this as IV, and the outcome that the researcher observes is called the dependent variable, or DV. To manipulate the independent variable, the researcher assigns participants to two different groups or conditions, one group who gets the supposed treatment or cause, and another group who doesn't. The group who receives the treatment is called the experimental group, and the group who doesn't receive the treatment is called the control group. Next, all participants are measured on the outcome or dependent variable, and the researcher looks to see if there is a significant difference on average between the experimental and control conditions. To examine how this works, let's go back to our example from the previous video looking at the relationship between exercise and sleep. In a correlational study, remember, the researchers don't intervene. They simply observe and record both variables as they naturally occur. In an experiment, however, the researcher would actually manipulate or change one of the variables. The variable that the researcher changes is always the presumed cause. So here we could manipulate or change people's exercise habits and see if that causes a corresponding change in their sleep quality. This would make exercise be the independent variable and sleep quality would be the dependent variable. To manipulate the variable exercise, the researcher would first create two groups, an experimental group who receives the treatment, in this case exercise, and a control group who doesn't. After recruiting people to participate in the study, the researcher would then sort these participants into either the experimental or control conditions through a process called random assignment. Random assignment is a process where the researcher uses a random factor, such as the roll of a die or a random number generator, to determine which group participants are in. So let's say that in our hypothetical exercise and sleep study, the researcher recruits 100 participants. For each participant, the researcher could roll a die. If the die rolls on an even number, then that participant would be assigned to the experimental group and would get some exercise. And if the die rolls on an odd number, then the participants would go in the control group. If we collect a large enough sample, then we should end up with roughly equal numbers of participants in both groups. So in our current example, we should end up with roughly 50 people in the exercise group and 50 people in our control group. After randomly assigning participants to either get some exercise or no exercise, the researcher could then measure the average sleep quality in both groups, such as by asking them to rate their quality of sleep on a scale from 1 to 10. We could then look to see if there is a difference on average in the sleep quality scores for both groups. Let's pause now for a couple application practice questions. Imagine that researchers are interested in whether being in a positive mood causes people to be more helpful. First, can you identify from Module 1 which type of psychologist might be most interested in this question? The correct answer is B, social psychologist. Remember that one of the topics that social psychologists are interested in is prosocial or helping behavior. Question 2. Now, let's imagine that our social psychologist decides to conduct an experiment. The researcher collects a sample of 200 participants who are randomly assigned to watch one of two short videos, either a funny video that puts them in a more positive mood or a neutral instructional video that puts them in a more neutral mood. Next, all participants are asked if they would be willing to donate 1 hour of their time to help another student on campus. Can you identify the independent and dependent variables in this example? Here, the independent variable is mood. This is because this is the variable that was manipulated or changed by the researchers. The researchers changed participants' mood by randomly assigning some of them to watch a funny video and others to watch a neutral video. Participants' willingness to donate is the dependent variable. Okay, let's go back to our exercise and sleep study. Let's imagine that after conducting this study, the researchers get results that look like this, where the average self-reported sleep quality in our exercise group was 7 out of 10, while the average self-reported sleep quality in our no exercise group was 5 out of 10. That's a difference or effect of 2. First, remember that we need to determine if this difference is statistically significant. If we get a p-value of, say, p equals 0.15, then this would not be significant. So that would be called a null result, and at this point the researcher would simply stop and conclude there's likely no true effect of exercise on sleep. However, if we get a significant result of p less than 0.05, then the researcher could say that there is a significant effect of exercise on sleep. So if we get a significant result, could we actually argue that exercising causes you to get better sleep? Remember, this kind of claim depends on the type of study design. And in this case, because the researcher did an experiment with random assignment, the answer is yes. But you might be wondering, what about the reverse causality and third variable problems we discussed in the previous video? Are those an issue here too? Couldn't there be some potential confounds or alternative explanations for this result? Actually, it turns out not. Let's explore why. First, reverse causality is not a problem because the researchers actually know in what order the variables occurred. The researchers manipulated exercise first, and then they measured sleep quality second. So we know that the change in exercise had to come first. Although in general it might be true that getting better sleep gives you more energy to exercise, this can't be the explanation for the results we got in our study because we know that the change in exercise happened first. So it has to be the cause of the effect here, and the change in sleep has to be the result. That's one major advantage to doing an experiment where the independent variable is manipulated by the researchers. But what about those pesky third variables or confounds? Remember that in a correlational study, we wondered if perhaps having a busy schedule could be a potential confound or alternative explanation for the relationship between exercise and sleep. But here, that can't be the case. Why? Well, having a busy schedule is no longer what caused someone to get more or less exercise. What caused them to exercise or not is what group they were randomly assigned to be in. It also can't simply be that some people just naturally sleep better than others. Although that's true, of course, it can't be an alternative explanation for the result we got in our study. Why not? Well, although people are, of course, very different in lots of different ways, when we randomly sort them into either the experimental or control groups, we end up effectively canceling out these differences. In other words, we should end up with some naturally good sleepers in our exercise group, but we should also end up with roughly the same number of good sleepers in our control group too. Likewise, our experimental group will have some people who are naturally poor sleepers, but our control group should end up with roughly the same number of poor sleepers too. And this should be the case for many other potential confounds like participant gender, age, background, personality, mental health, etc. So this is what makes random assignment so special. It essentially makes the two groups equal or the same on average at baseline. And importantly, if our experimental treatment, in this case exercise, is the only difference between our two groups, then our experimental treatment is also the only thing that can explain why those two groups scored differently on our outcome. So in this example, if the only difference between our experimental and control groups is that one group exercised and the other didn't, then exercise is the only reason why we would observe this change in sleep quality. As another example, let's think back for a moment to our social media and mental health example from the previous video. Instead of doing a correlational study, let's imagine that we do an experiment where participants are randomly assigned to be in one of two groups, one group that limits their social media use for a week and another group that doesn't. After a week, we could measure everyone's mental health with a self-report questionnaire. If we find that after 1 week the limited social media group experiences better mental health on average, then we know that reducing social media use is the only possible cause for this effect. While it's true that some people experience better mental health compared to others, remember that because of this random assignment, there shouldn't be a difference in the average mental health scores between our experimental and control conditions. In other words, there should be roughly the same number of people with relatively good mental health in both our experimental and control groups. And both groups should also have roughly the same number of people with relatively poorer mental health too. So if the only actual difference between these two groups is how frequently they used social media, then we know that this should be the only plausible cause for our observed effect. So as you can see, random assignment is a powerful tool. Because experiments are the only type of study design that use random assignment, they are also the only type of research design that can support a statement about causation. So why don't we just conduct experiments all the time? Why do we ever conduct correlational research? This is because, for all their benefits, experimental studies do have a couple important drawbacks too. First, in order to establish causation, experiments are often conducted in very controlled environments. Think about a chemist working in a sterile lab. The lab is sanitized in order to get rid of other chemicals or substances that could potentially contaminate a result. In an experiment, even in psychological research, we often do the same thing. Even though we don't go so far as to have the researchers or participants wear lab suits, we do often create very controlled settings where other potential background variables are minimized. While this helps us to isolate a presumed cause, it doesn't often match very well with what happens in real life, because real life is, well, messy. So sometimes researchers might still want to do a correlational study, where we simply observe variables as they naturally occur, to see if the relationship still holds in a real-world environment. A second important drawback has to do with the fact that it's not always possible to conduct an experiment in the first place, and that's because not all variables can be ethically or practically manipulated. To be manipulated, a variable has to be something that I, as the researcher, can change about you. And there are some variables, like age, that physically can't be changed. For example, I can't suddenly make you be 40 years old. Other variables that can't be manipulated might include things like height or past childhood experiences. Still, other variables are technically possible to be manipulated. It's just either very difficult or unethical to do so. For example, it would be unethical for me as a researcher to force some participants to do something I know to be harmful, such as smoking. An area where this is particularly relevant today is in regards to research on diet. You've probably all heard by now of various fad diets or superfoods that are supposed to help you lose weight, lower cholesterol, or live longer. I know I certainly see headlines like these a lot. Technically, it's possible to change someone's diet by randomly assigning some people to eat a Mediterranean diet, for example, while a control group continues to eat as they normally would. And there are some nutrition studies that do this kind of experimental work. However, this kind of study is very difficult and expensive to conduct. You basically have to provide people with food, which is expensive, and then hope that participants actually eat only the meals you give them. Because of this, most nutritional research is correlational in nature. That is, rather than manipulating or changing someone's diet, the researchers simply observe and record what people usually eat. And even doing that is difficult, as people usually aren't that great at remembering what they eat in a given day. And remember that correlational studies, no matter how well done, can never definitively show causation. So the next time you read about a food that supposedly causes cancer or a fad diet that supposedly reduces cholesterol, take it with a grain of salt, pun intended. Let's finish with the final application practice question. Which of the following variables could not be manipulated? The correct answer here is C, income. That's because I can't practically or ethically change how much money you make. But I could, for example, manipulate stress by exposing some participants to a mildly stressful situation. A common way to do this in psychology is called the tier social stress test, where participants have to give a public speech to an unresponsive audience. I think it's safe to say that most people would find this task to be a little bit stressful. I could also manipulate study strategy by having all participants learn about a novel topic, like how to change the brake fluid in a car. And then I could assign some participants to use different types of study strategies in preparation for a quiz over the material. In case you're wondering, there's lots of research that has examined what types of study strategies are most effective, and you can incorporate these into your own studying for exams. For a summary of what strategies researchers have found to be most effective, I recommend checking out the Learning Scientists website, and the link to this is provided under the Helpful Resources section on our Canvas homepage, or reading a book like Sandra McGuire's Teach Yourself How to Learn. In this video, we covered experimental study design. For the exam, you should be able to distinguish between experimental and correlational studies and identify each in an example, define independent variable and dependent variable and identify each in an example, describe the process of random assignment and identify variables that cannot be randomly assigned, explain why experimental studies can show evidence for causation, and discuss the benefits and drawbacks of experimental research.